Here I have drawn a rhombus. Since we know that a rhombus is a type of parallelogram, a rhombus has all the properties of a parallelogram, which means that the opposite sides, so this side and this side, are parallel to each other, and this side are parallel to each other. We also know that the opposite angles are congruent to each other, so this angle here and this angle here are congruent to each other, and this angle here and this angle here are congruent to each other. Also, in a parallelogram, the adjacent angles are supplementary. So this angle here and this angle here, when added up to each other, equal 180 degrees. Special properties of a rhombus are that all four sides are congruent to each other. So 1, 2, 3, 4, all four of these sides are congruent to each other. Also, that we know that when diagonals are drawn, the angles formed by the diagonals are congruent to each other, which means that the diagonal is an angle bisector. So these two angles are congruent to each other, and these two angles are congruent to each other. This same thing applies to the other diagonal. So these two angles are congruent to each other, and these two angles are congruent to each other. And when the diagonals intersect, the diagonals are perpendicular, which means that the diagonals form right angles, and right angles are 90 degrees. So all four of these angles are 90 degrees, and those are the properties of a rhombus. Here I have drawn a rectangle. The basic definition of a rectangle is a quadrilateral with four right angles. A quadrilateral is a four-sided figure, but a rectangle is also a type of parallelogram, which means that it has the properties of a parallelogram. This means that in a rectangle, the opposite sides are parallel to each other. So these two sides and these two sides are parallel to each other. We also know that the opposite sides are congruent to each other. So these two sides and these two sides are congruent to each other. We know that in a parallelogram, the opposite angles are congruent to each other. So this angle is congruent to this angle, and this angle is congruent to this angle. We also know that the adjacent angles in a parallelogram are supplementary. So these two angles, when added up together, will equal 180 degrees. We also know in a parallelogram, the diagonals will bisect each other and form a common midpoint right here. But there are special properties of a rectangle, and those special properties are that in every rectangle there are four right angles, or four 90-degree angles. So drawn here, 1, 2, 3, 4. In a rectangle, the diagonals are also congruent to each other. So this whole diagonal is congruent to this whole diagonal. Those are the two main properties of rectangles that distinguish them from parallelograms. Here I have drawn a square. A square is basically the combination of a rhombus and a rectangle. So that means it has properties of a parallelogram, rhombus, and a rectangle. So the properties of a parallelogram make it so these two segments are parallel and these two sides are parallel. And also, since it has properties of a rhombus, that means that all four sides, so 1, 2, 3, 4, all four of those sides are congruent to each other. Also, since it has properties of a rhombus, the diagonals in a square are perpendicular, which means they form right angles or 90-degree angles. Since it has properties of a rhombus, these diagonals act as angle bisectors and cut these angles in half into two equal parts. So this angle would be congruent to this angle. Since a square also has properties of a rectangle, that means it has four right angles of a rectangle. The diagonals are congruent to each other. So this diagonal would be congruent to this diagonal. This lesson may have been hard, so here are some quick reminders to help you remember these properties better. In a rectangle, there are four right angles and the diagonals are congruent. In a rhombus, there are four congruent sides. The diagonals are perpendicular and the diagonals are angle bisectors. And a square is a combination of rectangles and rhombuses. And finally, since all of these shapes are parallelograms, they all have the properties of parallelograms. There are some common misunderstandings about these shapes. A square will always be a rectangle in a rhombus, but a rectangle may not always be a square, and same applies for a rhombus. The rhombus may not always be a square. Okay, here's the problem. Quadrilateral PQRS is a rectangle. Find x. So since we know this quadrilateral is a rectangle, we know that all four angles are right angles. So each of these angles are 90 degrees. And since we know that this is 7x minus 4 and this is 3x plus 14, this diagonal is splitting this right angle into two separate parts. So what we do would be 7x minus 4 plus 3x plus 14 would equal 90, because this is a right angle or 90 degrees. So then we would add up our similar values, so 7x and 3x give us 10x, make negative 4 plus 14 is positive 10, would equal 90. So then you would subtract 10 from each side, and you would get 10x equals 80, and then you divide by 10, divide by 10, and x equals 8. Okay, now we're going to classify this quadrilateral and find the missing values. Since we see that there are 4 congruent markings, we can assume this is a rhombus because of the properties of a rhombus, because 4 congruent sides means that the quadrilateral will be a rhombus. Since we know that these two sides are congruent, they're going to equal each other. So y plus 8 would equal 3y. Subtract y from each side. 8 would equal 2y. Divide by 2. Divide by 2. 4 equals y. And since we know a rhombus is a type of parallelogram, we know that the adjacent angles in a parallelogram are supplementary. So that means they equal 180 degrees. So 104 plus x would equal 180. Subtract 104. Subtract 104. And x equals 76 degrees. Now that we have learned properties of squares, rectangles, and rhombuses, let's use these properties and apply them to real life shapes. Alright, first we have this shape here, and I'm going to measure all the angles in the shape. As you can see, this corner is 90 degrees, so we're going to measure another side corner. And again, I'll put this and these corners at 90 degrees. Alright, so let's measure the 2 remaining corners. And this corner is 90 degrees. And this corner is 90 degrees. So we know all 4 corners are 90 degrees. That means there are 4 90 degree angles. And using the properties of a rectangle, we know that this shape can be classified as a rectangle because there's 4 90 degrees. Now let's measure its sides. Right here, we can see that this side is 13 inches. So let's measure another side. We have another side that measures 13 inches. This side measures 13 inches, and this side measures 13 inches. So we're using the properties of a rhombus that has 4 congruent sides, which would make the shape a rhombus also. So since it has properties of a rectangle and a rhombus, we can classify the shape as a square, rhombus, or rectangle. We're going to measure the angles of this shape to see what type of special parallelogram it is. I've set my protractor to 90 degrees to see if this shape is a rectangle. As you can see here, this first angle lines up to be 90 degrees. So we're going to measure the second angle. And the second angle is 90 degrees. We're going to measure the third angle. The third angle is 90 degrees. And finally, the fourth angle is 90 degrees. Since the shape has 4 right angles, we can conclude that this shape is a rectangle.